In this example, I'm asked to use coordinates to determine whether this parallelogram, ABCD, is a rhombus, a rectangle, or a square. First thing you have to do is graph the coordinates. A is at -2, -1. Now remember, you have to run before you jump. So starting at the origin, count left 2, down 1. Here's point A. Point B is at -1, 3. Point C is at 3, 2. And point D is at 2, -2. Okay, let's connect the dots. We'll see what it looks like. Okay, it looks like I probably have a square, but to check this for sure, I'm going to have to use what I know about distance and slope. First of all, the easiest thing to check are the lengths of the sides. Again, distance formula is the square root of the vertical distance and horizontal distance between 2 points, squared and added together. So from A to B, I can count up 1, 2, 3, 4, and right 1. So this side is the square root of 4 squared plus 1 squared. That is 16 plus 1. That's the square root of 17. So let's count from B to C and see if we get the same thing. I have a horizontal distance of 4 and a vertical distance of 1. So this, again, is the square root of 4 squared plus 1 squared, which is the square root of 17. And if I count from C to D, I will see I have a distance of 4 and a vertical or horizontal distance of 1. So this is the square root of 17, and this is the square root of 17. So I've just established that I have 4 congruent sides. That means I have a rhombus. Now I have to check to see if I have 90-degree angles. To check that, I'm going to look at the diagonals. So I'm going to check the distance from B to D and the distance from C to A. From A to C, I'll switch to a green pen. I have a vertical distance of 1, 2, 3, and a horizontal distance of 3, and a horizontal distance of 1, 2, 3, 4, 5. So that is 3 squared plus 5 squared, which is 9 plus 25, square root of 34. Check from B to D. If I count from B to D, 1, 2, 3, 4, vertical distance of 5, horizontal distance of 3. It's the same numbers that I had in the last one. So this is going to come out as the square root of 34. That establishes that I have 90-degree angles on the corners. So this is indeed a square. It has congruent sides and all congruent 90-degree angles.